Hi guys, this is Jay here from Compy 281 and today I'll be giving you a demo of the multi-tenant UML parser application that I've deployed on the Amazon Web Services. For this, I've worked with four tenants, four students from Compy 202, and they've created the UML parsers, and I've uh, handled the backend, which is deploying the UML parsers on the EC2 servers, on the EC2 instances, and I've attached the auto scaling groups and load balancers to those instances. So let's get started. For now, let's just look at how the application works. As we can see, we have the four tenants listed over here: Umang, Divya, Labesh, and Avdeep. So let's just get started. We click on Umang, we see that the URL automatically changes. It routes through the load balancer to tenant 1. Uh, let's just take a test file. So basically what we are doing is we upload a zip to the EC2. We pass the zip of the folders which contain the Java files to the deployed jars. Uh, the jars then execute the UML, the logic, and they create a UML diagram which we pull back to the front end. So this is one of the test cases. So immediately, if you want to grade, we have an option of grading over here. But for now, let's take a look at the other uh, test cases or other applications. This is for Divya. The next one is for Labesh, and the last one is for Avdeep. I'm using all test case 4s as requested there. So we can see that all of these UML parsers are working and have been deployed on each instance, each separate instance. We can see it's tenant 1, tenant 2, tenant 3, tenant 4. So let's take a moment over here to look at how I've implemented the grader application. So for database, what I've used is I've used the RDS of the RDS service provided by the Amazon. Let's take a look at the configuration. So this is the RDS instance connected. It is listening to 3306 port, and this is the ARN or the endpoint that we have used in while connecting to the RDS. So what we are doing is, let's take a look at here. So these are the four tenants that I have created beforehand. The tenant data comments table holds all the comments, and the tenant mapping table holds all the mapping to the respective tenant and the fields that are associated with the tenant. So we are basically achieving multi-tenancy in database using extended table structure. So let's take a look at grading one of the. So let's take a look at one of the database queries that we'll be hitting. Let's consider Divya's. Uh, we'll consider Divya's test. Mm, and we give some comment. We click submit. So basically, the grading is done, and if you want to check it out, we go to the database, uh, pull the entry on the comments table, and Divya being TA2, this is the latest one, the comment good. Uh, so this is how we'll be using the RDS in our application. So let's just see how we have deployed the applications. Here we can see I have accessed 5 of the EC2 instances. The first four are where the tenants are deployed, and the Ubuntu instance is where the front end is deployed and it's being run. So now let's take a look at how what all we have done on the Amazon Web Services. These are the original instances, the front end, the tenant 1, tenant 2, tenant 3, and tenant 4. What we have done is we have created the auto scaling groups for each of them. Uh, let's just keep this tab open. These are the 4 auto-scaling groups that I've created for each one of them. They are running in the availability zones of 2A and 2B. So once the auto-scaling groups are attached to the instances, uh, the AWS instances are recreated, and we need to actually access the new created instances and start our services there before we can actually start our main front end and hit the APIs that have been created in the back. So 1, 2, 3, and 4 are the instances that have been spun up from the auto scaling group. Let's take a look at the target groups. We have 4 target groups. So we have the 4 target groups that have been exposed to the port 5000. Um, since all of our servers are listening, so since all of the servers are listening to the port 5000, all of the target groups have the port 5000 opened up for them. And finally, let's take a look at the load balancer that we've created. So this is the DNS name that we are using that has been generated for the application, and that DNS is being used to call right there. Depending on the tenant, depending on the API, the request gets forwarded to the respective tenant. Let's just see how we are doing that. Uh, so we go into the listeners and we edit the rules. Right. So here we can see we have done the mappings to the respective target groups. Tenant 1, if the request to the DNS is tenant 1, then we forward it to the tenant 1 target group, and so on. So what we are basically doing is uh, the request hits the load balancer. The load balancer then checks the incoming API request and it forwards it to the respective target groups. The target groups are then mapped. The target groups are internally mapped to the security groups. I'll just show you that in a minute. So these are our 4 auto scaling groups. If we just click on one, we can see that the target group it is mapped to is tenant 1. Similarly for tenant 2, tenant 3, and tenant 4. So what again, just to clarify the things, what we are basically doing is from the front end we hit the public DNS of the load balancer. Load balancer takes the incoming requests and it checks its mappings that we've made the load balancer listen to. The load balancer basically forwards the request to the respective target groups. The target groups are internally mapped to the auto scaling groups, and the auto scaling groups have the new instances spun up on them based on the load. And basically, what we are doing is we are hitting uh, the backend using this pattern. And that is how we are achieving, that is how I've configured the AWS services for my front end and how it interacts with the back end. So finally, uh, let's just do a complete demo from one end to the other. Let's select tenant 3. We choose a file for tenant 3. Let's say test 5 and we say upload. So this is the diagram. This is the UML diagram that has been generated by tenant Labesh Deshpande's code. Uh, Seeing it, let's say that I'm pretty happy and I want to grade it, grade the student, grade the student's code that he has done. So let's say the ID is something, uh, and the grade given is 50, and let's give it 100 and submit. So let's just go into the database and make sure that the grade for the tenant was submitted. There we go. Tenant 3 has graded it. Is given excellent, and there, right there. So he's gotten full marks. He's achieved the grade 100 from a total of 100. One thing I'd like to point here is the grading system for each of the tenant is different. Like the tenant 1 uses the grades A to E, and the tenant 2 uses the grades 1 to 5. Tenant 3 uses the grades in percentages and so on. So basically what we are doing is we are customizing the user input or the tenant input, and we are storing it in the database in the table tenant mapping. So we can see that tenant 3 stores the grades in the format that it wants. Tenant 2 stores the grades in the format that it wants. And again, we are achieving multi-tenancy in database using the extended table structure. So this was the application. I hope you enjoyed the demo, and thank you.